Yes.
Okay, so thanks to everyone online for messaging us that we were muted. You didn't miss anything fun. Trust me, it was just a bunch of boring, like this is being recorded, so you're all caught up now. I'm Jen, and apologies for that again. We do ask that if there are any questions throughout the chat or throughout the presentation, for those joining us online, pop them in the chat and I will read them out loud. For those in the room, David, do you want to pause during the presentation and be asked questions?
I'm happy to take questions at any time. More interactive, the better.
Awesome. For those in the room, raise your hand and then ask your question. I will repeat it so that the folks online can make sure to be able to hear it. And then we'll answer the question from there. At any time, if there is an issue with audio, for those of you joining online, please feel free to chat me directly. And that way we can monitor that throughout the presentation. With that being said, let's try to mitigate any kind of noise if we can. If you're online, please keep yourself muted. For those in the room, please help yourself to lunch, but it is picking up the audio from the room for those online as well. With that being said, we have David Simmons from Zymbit presenting Enhancing Resilience and Security and Update Rollouts. David, I'll turn it over to you.
Thank you. Hi. I've done a lot of these for Riot over the years, so I'm sort of familiar with this format. That QR code there will get you all my contact information if you're interested. It may come back at the end, I don't know, but if you need it, I'm happy to provide contact information. So let's just say hypothetically, you wanted to roll out an update to all your devices, critical update, and you decided to push this out on a Friday evening local time, and you pushed it to all devices worldwide. And it was a mandatory update, so nobody was given the option to say, no, don't apply that now. It just happened. And it was a driver update, so it was deep in the kernel and right. And now let's just hypothetically say that somehow your QA testing failed on that update, and all the machines that updated immediately went to a blue screen of death. And once you're in a blue screen of death, somebody has to physically be there to the machine to fix it, right?
Hey, David, sorry to interrupt. Can you share your screen so the rest of us online can see, please?
Christina, I'm seeing them in the screen share mode. Is it maybe a setting on your side that display like your view?
Okay, let me check. Thanks.
I can see it.
Okay, great.
Coming through on my computer.
Okay, great.
Awesome. Thank you.
So blue screen of death. I'll give you a minute in case you want to actually read it a little bit. It's not your standard blue screen of death, but anyway, guess who you are? Champions, right? And everybody gets a $10 Uber gift card or something for your trouble.
Not provided by Riot.
Not provided by Riot. So a couple of things I'm not going to talk about. I'm not going to talk about the gory details of what actually went wrong with CrowdStrike, other than those things that I sort of alluded to at the beginning, right? Mostly because I don't know them all, and because it would just be wrong to pick on them, right? And I don't want to pick on them. They've been picked on enough. I'm not trying to blame them or Microsoft for what happened. What happened. Of course, I don't know all the intricate details. I know enough. I've done a fair amount of research on what actually happened and what went wrong to know. And again, like picking on them would just be wrong, you know? So what I am going to talk about is how you can avoid it happening to you, because nobody wants that kind of internet fame, right? There's a whole side of Twitter that did I'm going to call it Twitter. You can call it whatever you want, but I'm going to call it Twitter. Where people posted the time they took production down, right? Just because Most people who have worked in production environments at one point in their career, they have done something and taken production down and had to fix it, right? I am going to talk about best practices for how to avoid this kind of failure, because it is possible to avoid it. And of course, avoiding it is what Zymbit does. That's what we do. So what did go wrong? Well, first of all, Friday afternoon deployment, don't deploy on Friday afternoon. Don't deploy on Friday afternoon. Don't deploy on Friday afternoon. Why not? Because there's typically not a whole lot of people around late on a Friday afternoon or a Saturday or a Sunday to fix whatever you broke. Assume you broke something when you push to production. Don't do it on Friday afternoon. Try not to push unattended updates, especially on a Friday afternoon. A forced update that everybody has to apply without being notified of it, right? Because some people, when you're deploying an update, are in the middle of doing something important with their production servers. They may be having a rush and they don't want their production servers to go down for this update, right? And you're pushing an update with no possibility to say, not right now, is going to take them offline, right? Yes,
Can I ask you, like, there's a tension there, right? Because
yes.
folks are gonna say, of course, do it Friday, that's when nobody's working. Like, so how would you suggest to push back on, or to justify?
That's where,
Can you summarize?
okay, so the question was, there's tension of, well, we want to do the update on Friday because that's when our, our servers are least utilized, right? And that's true, which is why you don't do as unattended, right? I can push on Thursday, but it's not mandatory, it's not unattended, and you can say, no, Thursday's my busy day. I want to apply this on Friday, and I know the update's coming, so I'm going to have some folks around for when it goes bad. Always assume the update's going to go bad, right? Always assume that your pushed update is going to go bad. Yes, you've tested it, but your QA may have failed. So driver updates are especially important to manage this way because they are deep in the kernel, and often they are even sort of at a pre-boot or right at the boot stage. And if something goes wrong there, guess what? It ain't going to boot. Critical production servers running on Windows. I would not recommend it. I never have. Seems like a bad idea to me. Windows is a desktop operating system. Yes, they made a server version of it. It's still Windows. Drivers run in Windows, yes.
You didn't make counter recommendations. You probably should after saying.
Linux
Okay.
or any other Unix operating system, right?
What was the question?
The question was, I didn't make any counter recommendations against Windows because I said, don't run Windows for production servers. Unix, some flavor of Unix, whether it's Linux or whatever flavor of Unix you want to get, something like that, right? Windows drivers run in privileged space because they're typically intercepting things like USB bus or network traffic or, low-level things. And if your update has a bad memory access or a null pointer exception or something like that, things can get very bad very quickly. And Microsoft's Windows approach to that is if loading a driver causes something bad, blue screen of death, wait for a person to come and fix it, right? Because if it proceeds with a very bad driver, you can basically render your system a brick, right? because drivers have privileged access to memory and disk and all the other stuff deep in the internals of the operating system, if it continued, there's no telling what kind of damage it could do, whether that would be recoverable or not. And it may end up that the system ends up being unrecoverable and you have to basically just pitch it, right? Start over. So what are some of the solutions? The main solution is to provide resilience for your updates, making sure that if something goes bad, there's a way to automatically recover from it so that you don't end up with all your servers going down and not being able to do anything. The estimate from Delta Airlines alone was $500 million from the CrowdStrike crash. That's how much they say they lost in that. And that's just one company. That's a lot of money. They are now apparently suing Microsoft and CrowdStrike to recover some of that. So you don't want to be in that spot. So what are some ways to do recovery? First one is A/B partitioning, and I'll go through what that is. And the second is A/B and R partitioning, so 3 partitions minimum, right? What is that? So A/B partitioning, you get a partition A and a partition B, and those are your boot partitions, right? And all your application and user data and everything else lives in a third partition down here, right? So you've got 3 partitions. Partition A, starting out, we know it's good. We don't care about what's in partition B because we're not using it. And all my user data is in there. When I apply an update, I apply the update to partition B. Partition A is known good. It's currently running. There's nothing wrong with it. It works. I apply my update to partition B. I reboot the system. If it comes up, everything's good, we just keep running out of partition B. And now partition A is our spare. And that's where the next update will go. If something goes wrong, and I failed my QA and didn't pay attention or did something stupid or whatever I did, and partition B won't boot, it crashes every time it tries to boot. Guess what the system does? It fails back to partition A, which is known good, know it can boot, know it can run the application. We're back up and running, and I can fix my update and try again to write something to partition B. Partition B is now bad, so I will continue trying to write an update there. Keep going until you get the update right. Hopefully it's only once or twice. You get it right, boots out of partition B, you run there until the next update. In fact, actually, if anybody has an Android phone, Android phones run this way. I'm not sure because I haven't been able to actually track it down. I think iOS devices run this way too. So anytime you apply an update, it applies it to a different partition so that your phone will always come back and you don't end up with a little brick in your pocket. A/B partitioning as before, but you have another small partition that's a recovery partition. Mac OS has this. If you go into the disk utility in Mac OS, you will see that there's this little partition that you can't get to and you can't do anything from, and it's a recovery partition. And it means that you can always boot the system to the recovery partition. So you write your update to partition B and it doesn't work, and somehow you did something really bad and it corrupts partition A as well. So neither one will boot. System falls back, boots to the recovery partition, and then requests a known good update and writes it to one of those partitions and comes back up, right? But it means that you always have a way to bring the system up. It's never going to just sit there at a blue screen at desk and, I don't know what to do, right? It's never going to require somebody to go up and hit a key on it. Because often, you've got racks and racks and racks of servers, and physically accessing each one of them to bring them back up is time consuming and extremely expensive. So this is actually one of the most secure ways to roll out updates. You always have, or in theory, you always have a good partition to boot and run your application from. And if for some reason something happens and you don't, you have a recovery partition that the machine can at least come up and phone home and get a decent update. Does all this make sense? Unfortunately, Windows doesn't do this. Windows has one giant system folder that is the operating system, and all updates go there live, and then it reboots, and if it makes it, it's a good day, and if it doesn't, it's a really bad and very expensive day. So here's that upgrade sequence, right? I'm booting from partition A. I upgrade partition B. This does not touch partition A, right? A is still good. B is now my boot partition, and I can run from there unless something goes wrong. If it goes wrong, A is still good, and I can go back and boot from there, and I can try updating. I can re-update partition B, right? Again, they both go bad. I can boot from my recovery partition. So I'm always able to get back to a good and running state no matter what happens, no matter how badly. And typically the recovery partition is read-only, right? So I can't write to it, so I can't corrupt that part of it. It's read-only. I can't screw it up. It's always there. In fact, that's how Mac OS does it. They have a partition there that you cannot access. Okay, so now we know how to do A and B partitioning. We know how to do safe updates to A partition, B partition. We make sure that we're already there. We're always there. The next step is security. An insecure update is as bad as a corrupted update. You cannot verify that it is what you intended to send, right? If it's not a secure update, I haven't digitally signed it with a certificate that the host that is getting the update can verify the signature. Now, this was all true for the CrowdStrike thing, right? All Windows drivers are security signed by default. They have to be, or they won't load. So this was true in that update. But an insecure update is as bad as no update, because you don't know, you can't be certain of what's being written. You can be certain of what you sent, but if it's not signed and verified, then you can't guarantee that it wasn't altered in flight. In an ideal world, you would not just sign it, but you would encrypt it as well, so that not only can nobody alter it in flight, but they can't see it either, right? Encrypt it at rest, encrypt it in flight, so that nobody can access what's in there without the key. And we live in a world where pretty much everything you do should be signed and encrypted, right? If you get email from me, you will notice all of my email is digitally signed with PGP, which means that if you alter one bit in that, the signature will not verify, and it's not what I sent. You can always verify that what I sent you, what you got is what I sent, by verifying that signature. And that's how updates work as well. I'm going to encrypt it and I'm going to sign it. Well, I'm going to sign it and then I'm going to encrypt it. And so you need to have the key in order to decrypt it and then verify that that's what you meant to send. So you have to start from a secure place. You don't necessarily have to, but it makes sense, right? So encrypt your file system. If you're running Mac OS, you probably have File Vault turned on, which encrypts your entire file system, and you have to enter a password in order to decrypt it, right? And when it first came out, it was really buggy, and people called it File Vault because it was really bad, and I lost at least 2 hard disks to being encrypted and not being able to get back. Encrypt your boot partition. And since what we do is Raspberry Pi and Linux, Lux is your friend. Lux is the Linux secure boot encryption, right? And in order to do that really reliably, the problem with Lux, if you know anything about using Lux to encrypt your file system, is that you have to use a key. But the operating system, the boot manager has to know where to get that key in order to decrypt the file system. So it stores the key in an unencrypted place on the file system so that it can find it to decrypt the file system to boot. I'm hoping you can see the security flaw in that. Small, and you can keep the key somewhere else, like on a USB drive, but it means that every time you boot, you have to enter that key, right? And that's where hardware security modules come in. Yes.
So would that like USB be the equivalent of a CAT card in the military where you have the encryption on the physical card and you plug it into your machine, like that opens and runs that machine essentially?
That can be, yes.
Okay.
Yes, yeah. So what is a hardware security module? This is one of our hardware security modules. It's called a Zymbit. And I will pass it around in case people want to see what it looks like. It's very small, very cute, but it packs a lot of power in there because it has a it's hardware security. So you can generate very secure encryption keys. You can store those keys in the module itself. Right? So secure key generation and storage. It's got a real-time clock, so you can't fudge the clock in order to get at the stuff on the key. Right? And it's also got some other tamper sensors, so you can't tamper with it. And if you tamper with it, it has this, if it's in production mode and you tamper with it, it does this really cool thing where it just erases all the keys. And if you used that module to encrypt your file system and somebody messed with it, when you try to boot, it will go ask the Zim key for a decryption key, and the Zim key says, I don't have any keys. Can't boot, right? But you don't have an encryption key sitting on an unencrypted part of your disk or on a USB drive that somebody has to go stick into the machine, right? It's always there. And the boot process knows to go and ask the Zim key for the correct key to decrypt the boot sector and boot the system, right? You can also use it for generating certificates and all kinds of other stuff. You can even use some of our hardware security modules as digital wallets for cryptocurrency.
Oh, I know.
Oh.
I'm just showing the folks online.
Yeah, so it's just a little bitty thing. And that actually sits on the Raspberry Pi. So here, people online can see one sitting. It just sits on the header pins of the Raspberry Pi. Thank you. Right. Easy to install. We have some slightly more secure versions of it. Actually, we have a bunch of versions of it, but yes.
So that little, something.
Yeah, you'd put one on each Raspberry Pi, right?
The one in your hand is all the same sort of.
Yes, this is just basically the same thing, and I can pass this around as well, except for all of the encryption hardware is potted in this thing right here. So it really can't be messed with, right? It can't be pried open. And again, this just sits on all the headers of the Raspberry Pi. So I can pass this one. And it has a little watch cell battery that goes on it to keep the real-time clock running all the time, right? So that even if you change the time on the Raspberry Pi in order to try to circumvent the security module, it's like, no, that's not the right time. You're lying, right? And you
What
can't,
happens if that battery goes dead?
I'm not sure how many years it's rated for,
Yeah.
but you replace it. And if it's on a running physical system, then you don't have anything to worry about.
Yep, yeah,
Yeah.
because everything's still.
Yeah. Yeah, it's all power, yeah.
Does your software monitor the battery? Following up with that excellent question. Now, in other words, let's say the server's running, so it doesn't need the battery. That's what it sounds like. Great. Well, your software should be saying, oh, it's down to 10%. Please replace it.
So the question was, does our software monitor the battery, the watch battery, to be able to alert you when it gets low? I actually don't know the answer to that right off the top of my head. I would think yes, just because the engineers that built this are really smart people, and I'd be shocked if they did that and then like got that part. But I can't say for certain. I haven't actually looked at that.
Sorry, before you switch.
Yep.
The very first bullet, you talked about physical tamper sensors. Can you
Yes.
elaborate on it?
So the one that's passing around right now,
Yep.
right? And this one, actually, they have tamper sensors on them. I will also at some point pass this around. This is one of our larger modules, right? If you try to do things to it, like send it a power surge in order to, basically kill the memory and get in, it knows how to detect those things. And its typical reaction so when I was passing this around, there's this little tiny tab on it, right? And when you're ready to go into production mode, you take a pair of clippers and you clip that tab off. And now, if somebody tampers with it, it erases its keys and bricks it, right? Some folks, and I will not name names, have decided that putting a Raspberry Pi on a drone is much more advantageous than trying to sort of write stuff that runs on the drone's operating system. It's much easier to just write your software on the Raspberry Pi, strap a Raspberry Pi to the drone and send it out, right? If you're sending out your drone in hostile areas, the last thing you want is somebody getting a hold of your Raspberry Pi on your drone. So you can actually set the tamper resistance here for things like high G-force. So the drone goes down, impact, high G-force. What does it do when it gets a high G-force? Wipes out its keys. So somebody comes along and finds your drone and finds your Raspberry Pi and thinks, oh, great. I get all their data and all their pictures and I know exactly how they're doing everything. No, they don't. Because it's all encrypted with a key that no longer exists. So it's useless, right? Yes.
What's happening to the physical server? Let's say it's not on the drone, it's on one of the racks of servers. What's happening to that? If there's freaking.
Physical server is different than like a Raspberry Pi, right? You're typically not putting Raspberry Pis in a rack. You can, and you can put a hardware security module on each one of those. And if anybody tries to break into your Raspberry Pi cluster, you can set the system so that it will wipe the keys and brick it. But these are, the main problem with a Raspberry Pi is when you deploy it in the field looking like this, that right there, that little card has everything. It has the operating system, it has my application, it has all my data, it has anything that I didn't send over the network is right there. And somebody walks up to it and pulls the card out and takes it home and puts it in their Raspberry Pi, and guess what? They have your Raspberry Pi now, right? They don't have to steal this. You can bolt this to a wall. All they need to do is steal this. But if I've encrypted it with this Zim key, even if they steal this card and this Zim key and take it home and put those two things on their Raspberry Pi, they will have the same result, because this Zim key has done a fingerprint of this Raspberry Pi. And so this Zim key, this Raspberry Pi, and this SD card all have to be together for it to work. Right? So if I take any one of these parts away, it no longer works. So now it's highly tamper resistant. You have to steal the whole thing in order to get it to work, right? Yes.
There ever a need to update the SIM key, or is the assumption that it's just something that you're gonna
So the question is there ever a need to update the Zim key, or is it something that typically, no, you don't need to update the Zim key. You can update the keys on it. You can generate new keys. You can add keys. It's got a whole lot of slots that you can put keys into. So you can have a key for decrypting the boot disk. You can have a key for encrypting the data that you're sending out over the wire. You can have a key, you can have multiple keys to do multiple things in the Zim key. So again, we've talked about most of this already. The Lux key management, your SD card is encrypted with a key for Lux, but that key is stored on the Zim key, not on the file system, right? Much more secure. Physical tamper security, somebody tries to take it, wipes out the keys, it's useless. So when we're talking about rolling out updates, we have this thing called bootware, which allows you to roll out updates to all of your Raspberry Pis in the field, right? And what bootware does is there's this trusted layer right down at the hardware, right, that we install. And you send, you make an update image and you sign it and you put it in a known location where all of your clients know where to find it with the public key. And when those systems they periodically check for an update, they see that update, they grab the update, they grab the public key, they check it, that it has been signed properly, that I can decrypt it, that I have the proper keys, and then I can apply it to either the A or the B partition. Bootware does the A/B partitioning automatically for you. So when you install bootware on the physical device, you get the A/B partitioning for you, so that it's always there. And it also creates a recovery partition. So you get the A, B, and recovery partitions. And bootware knows where to look. You tell it where to look for updates. And you can roll out updates to different machines by telling different machines to look in different places for their updates. You can either update the entire OS and everything, or you can, if you have implemented what's called file overlays. So this part is different than the boot in the OS, right? My application is in a file overlay. I can update just that part with bootware. So I don't have to redo a whole disk image and send you however many gigs of operating system and everything else, when all I'm trying to do is update this portion of the application that's in a file overlay. So we run on our own hardware, which I'll pass around. This is our secure edge node. I'll go through this in a minute, and it's in a clear plastic case, and the window on top is supposed to be a heat sink, and it's missing because it's clear plastic and the heat sink is metal and you can't see through it.
There was a question
Okay.
in the chat, and it was, can bootware, do application update as well, or only system or OS update?
It can do all three,
Okay.
okay? In order to do sort of application or other updates, you need to put those on as what's called a file system overlay, right? So that can be updated, right? Yes.
Are there any either memory or processing requirements? I think of like a lot of edge IoT devices are extremely lightweight. So is there like a minimum capability that you need in either compute or transmit receive or memory to practically use this?
You need basically, so the question is, are there minimum compute requirements for this? So right now, bootware is for Raspberry Pis,
Yeah.
right? So Pi 4, Pi 5, right? We are working on other ways to update other devices with bootware,
Yeah.
right? So what bootware does is this trusted execution layer holds the actual Raspberry Pi boot in reset, right? While it goes and verifies the signatures of all the boot files and all the stuff that it needs, right? So our supervisor process does that while the Raspberry Pi is still in reset mode. And if it verifies everything, it decrypts the files and then loads them into memory, and then it releases the main processor to go ahead and boot using all that stuff that's been verified and decrypted. Right? It's a really secure boot process. It's not actually even relying on the Raspberry Pi processor to do these things. It's actually got a supervisor processor that's doing these things before it even turns on the Raspberry Pi's main processor. So the process is, and we don't have to go through all of this in detail, but I create an image for my secure compute module. I then take it and I take it to an encryption station where I encrypt it and sign it and do all that. I put the encrypted image with the public key in a known location. Does somebody else have a question?
Question on the
Okay.
chat, yeah. It says, third-party signal board computer like Pine 64 may not be tested yet, but if it has Raspbian OS installed, should it work?
It's funny you should say Pine 64 because I have a pile of Pine 64s in my office, and just yesterday I was trying to verify this. And unfortunately, my version of Armbian is too old to even update. So I'm having to like basically re-image them to try this. It should work. But I haven't tested it, right? We have verified that these keys work on on the Jetson board and Raspberry Pi. If anybody is addicted to Kickstarter like I am, you will know that Particle has started a new Kickstarter project for a Raspberry Pi size board that also has an AI coprocessor on it and an integrated cell modem. I've of course ordered a couple, and my first order of business will be to see if a Zymbit works on that. Yes.
So with these types of trial and error kinds of things, like two questions. One being that, like, what happens? How would you know if it works or doesn't work if it hasn't been, like, if I plug the Zymbit into something, and then are you looking for people who are interested in doing that?
Well, I mean, there's a couple of things there. One is there's a difference between it works and it's supported, right? So it can work just fine, but is Zymbit going to support it? That's a different thing, right? Because we need to make sure that it's something that is repeatable all the time, works all the time, and there's not like weirdnesses that we have to account for, right? In theory, yes, it works. Does it work 100% of the time, all the time? We haven't qualified that, so we wouldn't be able to support it. Right?
And I just want to, for those in the room, Christina with Zymbit posted in the chat that Zymbit does offer free versions of bootware up to 10 devices, and I send the link around after.
Yes. I should have mentioned that. Yes, up to 10 devices, free version of bootware. You can try it out. The nice thing about these Zymbit is you can also try these out. I don't recommend trying them on a production one first time out, but until you clip the little tab, it's not in production mode, right? Now, I have managed to foul up my Pi 5 several times with my Zymbit, right? But I wasn't really doing anything important on it. I was just testing it. So I just pull the card out and I re-image it and I start over, right? That's not possible with production machines. So what you want to do is make sure that you know what this process is and you have everything down before you start applying these to production devices. Right? Because if you don't, and you screw something up, you got to start at the very beginning, right? So I'm going to sort of skip ahead here. We have these Zymbit 4s. We have these hardware security modules and secure key managed wallets. So we have a couple of versions of these security modules. We sell just this thing here in the middle, which is a Raspberry Pi compute module, but it is potted with the supervisor processor and the basically the Zymbit, right? So it's one thing. And it's pin compatible with a Raspberry Pi compute module that you can buy off the web. It just has this extra security in it, right? And then we sell these secure compute nodes. Right? And the secure compute node, I don't know if anybody turned it over and saw these little red buttons on the bottom. Little red buttons on the bottom. Those are pressure sensors. So if you pry it open and you've set a perimeter alarm for the pressure sensors, guess what it does? Wipes out its keys. So somebody steals your box and pries it open, they've just stolen a small brick, right? There are lots of other sensors in here. G-force sensors, we monitor the power. so that if you try to spike the power in order to put the processor into reset so that you can get at it, we'll stop that. There's a whole bunch of ways that we make this very, very, very tamper-proof. So it's really secure. And this is, again, our secure compute module. It's got the hardware element baked in. It's got a real-time clock baked in. It's got so what we call a last gasp power monitor, so that it will monitor the power until it just can't anymore. And all of these things you can set alarms around. So if anything happens with any of those that you want to make sure doesn't happen, you can set an alarm so that it can first notify you and then kill itself, or just notify you, or just kill itself. So it's configurable for how you want to handle all of this. Again, the secure compute module is just a Raspberry Pi compute module, and you can put it on any board that will accept one of those. We make a developer kit board that you can put one of those on to develop what you want, so that you make sure that everything works, right? We're running out of time, so I'm going to sort of speed up here. You can see in this diagram that it's a tamper-resistant enclosure. We've got our hardware security supervisor in there. As another layer, there's more tamper-resistant potting on top of that. And then the Raspberry Pi compute module goes on top of that, right? And if you try to pry that apart, it won't work, right? Very secure. All right, so if you want more information, you can scan that code. That will take you to our website, basically. And you can get more information there about the Zym keys, about secure compute modules, about secure edge nodes, about bootware, all of that. All of our documentation is there. There's a store there. You can buy stuff right off our website, wherever you need. Questions that haven't been asked already?
Thank you so much. Does anyone online have any questions?
I will say that I've talked to Tom about this, and what I'm sort of trying to figure out how to do is to run a hands-on workshop with Riot, where basically you get all this stuff and we come in and we work through how to install it, how to configure it, how to secure it, how to do all that stuff, like hands-on in person with the devices, right? So if you're interested in something like that, let me or Tom or Jen know, and we'll see what we can do to pull that off.
Part 2 of this lunch and learn.
Yes.
There's a question online that said, are there any IEEE regulations for offensive security management versus defensive security management?
I'm sure there are. Do I know them? I'm sure I don't.
Just polling the room and online, like, is there interest in hands-on hardware? Yep. You have lots?
Yeah.
Cool. Yeah, I think we can try and we'll work to set that up.
Okay.
Any other questions?
I'll ask a question that's maybe not quite as Zymbit centric yet.
Okay, yeah.
Hopefully in the future, but you know, if you've got you got a bunch of edge devices that you have developed in some way that are not Pi-based necessarily, but you're interested in this kind of security, like what other options are there today, or what's coming in the future for?
So
Summarize.
the question is, if you've got a bunch of edge devices and they're not Pi-based, are there other solutions or is there stuff coming? There are other hardware security modules out there. If you're Linux-based, whether it's Raspberry Pi or not, you should be able to get one of these to work, right? It just uses the I2C bus and a 5-volt power and a ground, right? So you should be able to do that. Like I said, I've got a bunch of other boards and it's on my list to like see what I can make work. If you're running x86 based boxes, we are talking about making this stuff available for x86 boxes. So
Will you, if someone's building a custom board, like at a certain volume breakpoint, will you help to embed your tech directly onto those boards?
I guess it depends. I mean, if they're building their own board and they want to put a Raspberry Pi compute module on it, then that part's done, right? Because all I got to do is buy the secure compute module from us, and it's pin for pin compatible, so they can develop their board with a Raspberry Pi compute module, right? And then when they're ready to deploy in secure locations, they pull that off. They put one of our secure modules on there with their OS and all their stuff on it, and they're good to go, right?
I think that that's all the questions that I'm seeing. I'm not seeing any more online. Thank you again
Thank you.
for a wonderful presentation. Thank you all for coming and for joining us online. We try to host these weekly on Wednesdays at 1 p.m. Eastern time, and you can find all of our events as well as an event that we're hosting here at Carry Founded tonight at 5 p.m. That's also free and open to the public. So hopefully if those joining us online can come join us in person. And for all of you in the room, you're welcome to hang out here for the day if you'd like to co-work, or join us back at 5 o'clock. Thank you again. And we will be following up with the recording and hopefully some hands-on stuff in the future. So yeah, thank you.
Cool. Thank you.